Hello everybody and welcome to another week of CS 202. We have 2 weeks left of class, this week and then study week, and then we got the final. So this week we have Thanksgiving on Thursday, but we may or may not have a class on Wednesday. In fact, if we can finish the double linked list today, then we won't need to have class on Wednesday. But if we don't, then we might need to have a class on Thursday, so we should be able to finish it though. But that's kind of the plan. And then next week we are going to do stacks and queues. And for stacks and queues, what we'll do is we'll probably spend about 1.5 classes on that, and then the remainder of the second class will be a review for the final, if we have that extra time. And so I have updated the rewards on Twitch so that you can claim extra credit points for smaller amounts than the 300 points, which I would like to only use if you don't think you're going to make it to 10,000 by study week. Okay, so that should be available. I literally just did that right now, so I don't know if I have to. Maybe I have to restart the stream. Who knows? But if not, then you can do it on Wednesday. Okay, so yeah. Okay, let's get started then. How about that? So I hope you all had a good weekend. The linked list assignment has been posted, so you can get going on that if you so choose to. So, all right. So today's topic is actually kind of two things. We're going to do a little bit about sorted linked list, but the main focus is going to be a doubly linked list. And to quote a modified version of Star Wars quote, twice the links, double the segfolds. So from Count Linked List Dooku, I guess. Okay. So let's talk about that. So I mentioned very briefly at some point what a double linked list is, but let's actually kind of refresh that before we start coding. Okay, so to do that, let's talk about what a single linked list is, which is what we've been covering so far, like every single day for the past more than 2 weeks now, I think, because we had the test in the middle. So a normal or a singly linked list, whenever you hear the word linked list, you're talking usually about a singly linked list. And what that is of course a node that has some sort of data component. This data component may be actual data, like static variable, but it could be a dynamic variable in the sense that it's a pointer to the actual data being stored somewhere else. Either of those work. If it's a pointer, then here's the data, and then that's just a pointer. But you don't usually see that when somebody's drawing the linked list, because it just makes more sense to do it this way, even if it's a pointer. And then the other part of the linked list is usually known as the link component, or what I've usually called it, the next component. And what that is a pointer of the same type as this node. So it's a node pointer. And what it is it's meant to point to the next item or the next node in your linked list, right? So you chain these together. Now, what do I mean when I do the little circle here is I mean that it's usually set to null until you actually link it to something, because my example that I've given you enough times now is, again, think of this like a building bridge, and each of those links is one more piece of the bridge. And then while the bridge is in construction, or even, at any point, you want to make sure you put a road close sign so cars don't drive off the bridge, right? So the null pointer is that road close sign. So anyways, that's a singly linked list that we all know and love. And so the disadvantage to the singly linked list is that you can only go in one direction, right? So it's kind of like a one-way road. You can only go that way. And if you want to go back, you can't. You have to either circular, which is where you make that point, the last item of the node point to the beginning. And then, it's kind of like saying, okay, well, here's let me draw a poorly representation of the United States. Okay, so that's like the US, I suppose. Imagine that we had a highway that was kind of like this, okay? But it was only in one direction. So like, I guess this highway is not going to California, I guess. Right now I went to California. Okay, so maybe this is like Route 66 or something, okay? So like, let's say that this is like LA, and then this is like Phoenix or something. And this is not to scale, okay? So if it was one way, and it only went in this direction, and you wanted to go from like LA to Phoenix, from Phoenix. Well, okay, let's say you want to go LA to Phoenix. That's okay. You hop on the highway here, and then you just kind of drive here, and then you're there. And it was pretty nice, fast path, right? Okay, but now you want to go back home to LA. Well, this is a one-way road, so you're gonna have to go all the way down to Florida, then to like, I don't know, North Carolina, where that is, like Chicago, somewhere north, and then, you know, back here. And well, that was a really fun road trip, but not very efficient if what you wanted to do was just get home quickly, right? So what do we do with roads? We make them not necessarily two-way, but we add another direction of the road, right, to go the other way. But it could be a two-way road, actually. Like some really small roads have that as their, you know, like back roads don't really have a two-way system. It's just a road, and, you know, you just go whichever way you want, right? It's like a dirt road or something, right? So it's the same issue that we have with linked lists, that you can only go in one direction if it's circular. Alternatively, let's say that we, you know, most linked lists have some sort of head pointer, right? Which is in the beginning of the linked list. That would be like if we put a head pointer maybe at LA, okay? So if you want to go if you want to go to Phoenix in general, the only way that you can enter this road is through the head pointer. So, okay, that's not bad. We just kind of go here. Let's say you want to go to Tallahassee over here. Well, if that's the case, then you still go into the start LA, go to Phoenix, and then keep going until you get to Tallahassee. Okay, let's say you want to go to Sacramento up here, okay? Well, because it's a singly linked list, you're going to have to go through Phoenix, Tallahassee, again, all the way around until you get up here, which is pretty inefficient, right? So what can you do? Well, you can add a tail pointer if this was like if it was a linked list, so you can get to the end of the linked list. But that's not going to help you when you get to the second to last item of your linked list, right? So if you actually draw like a proper linked list here, so we have this linked list, and then, you know, we have a head pointer so we can quickly go there, and we have a tail pointer so that we can quickly go to the end. So like what that allows us is we can very quickly append things to the linked list. That's great. But what if we want to go somewhere in the middle? Well, it's a single linked list, so we have to start from the head and go there. In fact, the most inefficient thing to go would be the second to last item, because the tail pointer is not going to be able to make you hop back one time. You have to go all the way here, which is like in the scenario here that you want to go to Sacramento. So you have to go all the way around, right? So the solution to this is, after all, this is just pointers. So why don't we just add another pointer, which I will represent as a square on that side, with an arrow of its own, because it's a pointer, which we can also set to null initially. And that pointer we are going to call previous. But again, you can call it whatever you want. And now, because it has not just a single pointer, but a double pointer, then this becomes a doubly linked list. Now, what can we do with that extra pointer? Well, that pointer allows us to go in both directions of the linked list. So if I update my drawing here of the linked list with such pointer, actually, it might just be better to draw a new one because it'll get really messy. So let me do like a really nice link, and then I can just copy and paste it. Hang on. I know what I'm gonna do. All right, let's try that again. Let's make a really nice rectangle with some really nice lines and some very pretty arrows. And then, while we're at it, we can label it. So we got data. I'm just gonna put N for next and P for previous, but and here's my key, just FYI. And now let's just copy and paste a bunch of these. Now you can see why I did the arrows like that. Okay, and then maybe drag that over. I think we can maybe fit one more in. Actually, we can fit a lot more in. We have to think that the pointers are not necessarily in the same spot in memory, right? So what we can do is, we can do it like this. Then we just gotta update these pointers. Oh, I didn't want the lines to cross. There. Okay. And then set this one to null, and set this one to null. And then put our head pointers still to the first one, and the tail pointer still to the last one. And in this case, the tail pointer is actually very, very useful. Like you want to have a tail pointer. Otherwise, you kind of lose the big power of the doubly linked list. So now we have the ability to enter our linked list in two spots, the head and the tail, which is the same as before. But here's the cool thing. With the head pointer, sure, you can go forward, no advantage gained there. The real advantage gained is the tail pointer. So the tail pointer now, you can go backwards. So you can start out at a tail, and yeah, you can still append things here if you want, but you can also go backwards as necessary. So like if you wanted to go here with that Sacramento example, you just go one link back. So now, if we go back to thinking about the map, what we're saying is we have a head pointer and then we have a tail pointer. Let's say it's at Sacramento. There's like no piece of road here for some reason. Okay. So if that's the scenario, then if we want to go like, let's say to Chicago up here. Okay. Okay. We like forgot to add the Great Lakes and all of that stuff. So there you go. Okay. So in that case, it's faster to start from the tail pointer and then just drive this way than it would be to take the head pointer, right? Okay, or like let's say we wanted to go just right here. Then of course we want to take the tail pointer. But if we want to go to Phoenix, we still take the head pointer, right? So that's the big advantage of this. But now, it's a good advantage, but it doesn't automatically solve the problems that we have with the linked list, right? Which is seek time. So with an array, again, you can immediately go anywhere in the array. Like you can just select an index and then bam, you're there. Like it's like teleporting essentially here on the map. With the linked list, with a double linked list, you cannot get around that problem still. I mean, it's better now because like instead of, let's say, the worst case scenario being essentially the entire list, like having to run through the entire list to get to the second to last item of your linked list, which would be this one in a single linked list would be the worst case scenario of what you want to access, delete, or whatever you want to do with this. Now, the worst case scenario is really just the middle of the list. So you can think of it, I know you'll learn about this in Trio 2 with time complexity, but you can think of like the searching time to find a node in the worst case scenario, which would be the second to last, instead of being basically n-1, with n being the number of nodes in the list, is now n divided by 2. So it's half the time, which is, for the time complexity people, it's still the same. But for us, without thinking about that, it's still better because we cut the time in half, right? And that's okay. So anyways, that's kind of the big thing about the double linked list. And there are some data structures that it's useful to be able to do this both directional thing. It definitely makes, this is a two-edged sword, kind of like the double linked list with 2 pointers. It is in a way like that, a two-edged sword, because it's easier to insert things because you no longer, when we were inserting before, we had to if we're inserting or deleting, we had to keep track of the node before. So we had to do some nasty code to be able to do that. Now you don't need to worry about any of that. You just need to have a pointer pointing wherever you want to delete, because you can very easily access things before and after. That's the advantage. The disadvantage is that because each node has 2 pointers, you got to deal with more pointers, which of course, when you're dealing with more pointers, it's potentially more risk of sec fault, which is where that little quote came from. Is it half the time because we'd be searching forward and backs at the same time? Yes. So it's you can think of it that way because remember, when you are seeking something, you're saying I want to get like the 5th item of the list, right? So if you're searching for like the 5th item of the list, then if you know the size of the list, you know from which direction to start. So it's like if you're looking on the map, if you want to go somewhere, you know which way to start because it's shorter, right? So like if you're something closer to this spot than this spot, then you start here. But if it's something like right in the middle, then it doesn't really matter. So that's more of what I'm referring to. If you're searching overall, so like if you're giving a list and you're just like find if this number is even in the list, then it's irrelevant whether you use a singly or doubly linked list because you have to search the list anyways. And you still end up in that worst case scenario, which is that it's the last thing that you look for, which is essentially means that you have to look at the entire list as a whole. So don't worry too much about that whole time stuff. That's like the first month of 302. So whether you take it with me or anybody else, we'll walk you through the whole time analysis and space analysis stuff, big O and all those fancy terms. But anyways, for this class, what you just should know is how the basic double linked list work. So that's pretty much it. I mean, like, this is it. I could call it a day now. If this was like a 302 class and we were reading linked list, this is where I would call it a day. However, because it's 202 and because it's good to code, I think the rest of the class is basically going to be, let's just implement a double linked list. But in this case, so that we can see what a sorted version of it is, we're gonna do like a sorted double linked list, which what that means is that it will, when we call the insert function, it will automatically insert in the right spot of the list. And that's going to be using something kind of known as insertion sort, which is where when you have a number, you insert it into a list that's already sorted. And if it's not, then it's just an empty list, which we consider a list with one item or with no items to be sorted, because I mean, it's just one thing. It's like it's sorted, right? If I tell people stand in line by alphabet name and there's only one person there, then it's impossible for him to be in the wrong spot. So, but when you get a second person in the list or in the line, then you have to ask, okay, where does this person go? In front or behind the person that's already in the line, right? So checking for that to see where you go is how insertion sort works, and that's how we're gonna code this. So it's a very inefficient algorithm. It's like bubble sort, but it's easy to implement for a linked list, and that's what we'll do. Don't worry. Again, in 302, we'll learn all these cool sorting algorithms like quick sort, merge sort, and heap sort, but not yet. Okay, so I don't really think there's anything else that I want to say about this. I could write code here, but I'm gonna write it again in the computer, so I might as well just write it on the computer, save time. So yeah, let us begin, or shall we begin? Okay. So I still have open here for reference the single linked list that we did. I might copy and paste some things from here just to save time. Otherwise, it's going to take us a long time to code this. But not long, but you know, because if I was just coding it and not talking, we'd probably finish in like 10 minutes. But talking and coding and then fixing bugs because of distractions makes it take longer. All right. So let's first start with copying the, first of all, we should make a choice. Do we want to make a template? Let's not make a template this time, because that just added so much more time. And you already saw an example of templates. So that'll make it faster. Plus we can modify it and make it templated later. So we can still make the, we might be able to, can you do that? Can you extend a class as templated? I think you can, yes, yeah. So we can still make the node templated, but when we make the double linked list class, that's not gonna be templated. We're gonna hard code the node. I think we can do that. We'll try and do that. That's a good example, okay? But anyways, we have our node class. So we're gonna modify this slightly to add that previous pointer. So that is as easy as saying node star previous. Bam, I just added a previous pointer. Now, because I want to initialize that to null, because now it's like, okay, we're building the bridge, but we can build in two directions. So we need to have a road close sign in that direction, but also in that direction. So we don't like, it's like, imagine we're building the bridge in the middle of the ocean, and we're like let's say we're doing like the stretch of Bering or something. And like we're trying to build towards Russia and towards the US. And like we're just building from the center, so we need to have road close signs on both sides until like, you know, they get to like land or something. Okay, so yes. So I think it's a good idea to actually set that in the constructor, so we can do that here next to the next one, so next to the next pointer. So this next is being initialized to null, so now we're also going to say the previous initialized to null. So that way, you know, we don't have to technically do this. We could do this when we create a node, but it's just an extra line of code every single time, which if you forget, it's even worse, because then, you know, like it's better to always start things with null, because then if you get a null pointer in a section, that's better than like having actual invalid addresses in your pointers, which is a lot harder to debug, because you're like, okay, this is not null, but it's not working and it's crashing, and it's just, you don't want to go down that road. So take advantage of the constructor always. Okay, so that's pretty much all that there is to modifying in this to make it a double linked list. So now it's a matter of making the class. So we're gonna call it double linked list class, since that's kind of a good name, I suppose. And it's going to contain just a single pointer, which actually, no, sorry, two pointers, the head and the tail. So you know, we should probably make them private, but I'm just gonna start with everything public, and then we can modify this if you have time. So let's make node pointer, but in this case, because I don't want to have to deal with templates, I'm just gonna hard code this to work with integers. Actually, do we want to do integers or do we want to do chars? Do you guys have any preference on the data type? We could do characters, and we could make like a nice little pretty like alphabetical thing. We could also do numbers. We could also do like actual floating point numbers. So we could do like decimals. I don't really want to do anything more complex than that because we have to overload operators. But yeah, so you guys have any preference for numbers or characters? Characters. Okay, we're doing characters. So there you go. And like I said, we actually will be able to very quickly modify by just changing one line. So that actually will, you know, we can try it later to do it the other way. But anyways, so we got cars, and then this is going to be a head pointer and the tail pointer. So I think that will compile, but let's just check to make sure that it actually does. Because this is a template template variable, we'll see if it complains. So are we in folder 14 now? Oh, this is 15. So cd cd 15. Okay. It's lagging. Okay, there we go. It would like lag for a second there. Okay. DL1, not CPP. Okay, especially initializer. So class. Oh, I shouldn't have added spaces there. Okay, so that compiles, so we're good. All right, so we are using a templated class here, but we are defining that, so we don't need to make this class itself templated. So that's kind of nice about that. We could have, like we did the first one, the singly, but no point in doing that. It adds extra time. Okay. So let's look back at the singly linked list and see what kind of stuff we had. So we had the constructor, which we should definitely have, which is pretty much going to do the same thing as this, initialize the head pointers and all, but also the tail. And then we are really going to combine all the inserts into just like a insert because it's alphabetical, so it'll choose for us where to insert. We can still have a search. In fact, we might be able to copy and paste the search we have on this one. Same with the print. We probably would just want to copy and paste that. And then we could also have a delete. But not delete add. We'll just say delete as a specific character, and it'll like search and delete it. And then a destructor as well. Destructor would also be probably the same. So let's start by actually just copying and pasting this, and then modifying it. Okay, so first let's go ahead and get rid of all of these and just create one called insert. And it'll insert a character. And then let us go ahead and, you know what would be cool to do? Could it work? Yeah, it could work. I haven't used it in a while, but let me just really fast Google to make sure I remember how to do this. It's a Typedef. Because it might make it easy to modify things later without using templates. Yes. Yes, okay, so we're going to use a Typedef so that we can modify this later very easily to use other data types without using templates. So I'm going to say Typedef car, and then it's going to be called car, or we'll call it var. Yes. Do I need a semicolon with a Typedef? Hold on, let me check. I do. And here's some information about Typedef if you don't know what that is. Typedef is like making just a alias for a identifier, or it doesn't have to just an identifier. It can be a keyword. It's literally saying that wherever it sees the word var, it's just going to replace it with the word car. And so what I can do then is I can use the word var in everything here, and the code will compile, but then it will replace the word var with car when it's compiling. The reason why I want to do this is because then later, if I want to try to make this out of integers, I can just change that in code and it'll work. So it's not quite a template, but I think it'll work. Okay, we gotta get rid of all the other things before we can compile. I forgot about that. So yeah, we'll do that to make it more flexible. Okay, so let's go ahead and make a constructor. So that's the same thing as a destructor. Does the 23 need bar? Yeah, all this stuff needs bar. We'll modify it. I just copied and pasted it. We'll get to it. So, but yeah, it does. Okay, so first let's fix the constructor. So we changed the name here to the right class name. We are going to add the tail as null as well. And that takes care of the constructor. The insert, we're gonna put bar like that. The search, we are going to, for now, just let it be like that. Search for something, and then returns the location. Sure, why not? I don't know if we'll have that. We might delete that function. We can have a delete that deletes a specific car. And then the print function, we are going to modify by making a temporary pointer of the same var here called cur. Then the same thing here, cur print. Oh, do we need to modify cur print? Yeah, we need to modify that in the base class. Cur next, so that's all the same. And then here, let's change this to doubly so that it compiles. And then, well, head is not equal to null, node var temp. I could also use the word car, by the way. It'll compile too now, but not later when I switch that to whatever I want. And then, okay, so that will all compile. But anyways, the reason I said we need to fix this is because this printing, we're printing the data, and then we're printing the next component. But let's print out the previous pointer, because that'll actually be nice to see. So not more of a fix, but more of an upgrade. So in addition to printing next, we're gonna print previous. So previous like that, and then prep. What this will do is when we print out a node, like when we're printing out the whole node, it'll print the node data, the next pointer, and then the previous pointer, so that we can see both pointers. So we will also be able to see how the addresses match. So I think that is good. Yeah, that's good. Okay. I think this should compile minus whatever typos we have. Okay, so we just got one delete on line 21. Delete is like grayed out. Expected unqualifier, so there's something bad above it. Okay, it might be because the word, I know what it is. Delete is a reserved keyword because of the delete. You know, when we do delete this, it's a reserved keyword. So because it's reserved, you can't use it as an identifier name or a function name. So we'll just make it uppercase D for delete and get around that. Okay, so that's why it was giving us that error. It's like if I try to call a function like int, it would be like, no, int is a data type. Don't make a function called int. That sounds horrible. However, if you were using Python, then it will let you do it. You just lose access to all integers. So yes, that's out. We're not coding in Python, we're coding C++. Okay, so we got basically the basics of this in here. We have a constructor, we have a print function. We still need to do the insert, the search, and delete, which is the meat of it. But this is good as it is now. But before we go any further, let's move this outside the class so that we have space, because otherwise we'll run out of space very quickly. So let's start out by moving the print function outside. Okay, press Shift Tab to move it back like that if you don't know that. And then just write double length list scope versus an operator, and that's all we need. We don't need any templated nastiness right now. So we're okay. And then let's do the same thing with the destructor. Doubly length list. Okay. And then we don't really need to do it with the constructor because it's just a single line anyways, so there's no point. So good enough like that. Okay, so now we have like nice space. So we need to do those three functions. So I don't forget, I'm just gonna write the bodies of them for now. And then let's go ahead and write doubly length list, colon. Let me just copy and paste. Laziness. Okay, so, yep. Put those. And let's put those. And I think that's as far as we're gonna go. I'm gonna write some main code to test what we have so far before we do any of that. So let's go ahead and start by, actually, let's look at what we have in main code before. Do we have anything we could just copy paste from this? Wow, this is a lot of code. Oh, we have all the inserts, but we can't really copy paste them because we're gonna modify them anyways. Oh well, that's fine. We'll just go ahead and make her. So what we'll do is we'll make a double linked list object, and then we'll insert a bunch of letters into it, and then we're gonna call maybe like the search function and maybe like delete one or two things, and then that'll be it. So let's just write that test ahead of time. So doubly linked list DLL, or just call it, yeah, DLL, double linked list. And then we can say DLL dot insert, and then we can insert like, again, we're gonna have to test. See, so here's the thing with the insert. It's still the same as the insert for the single linked list, that we have the 4 cases where the list is empty and we're just inserting something. That's one case. And then the other 3 cases are when the list is not empty, where we're inserting at the beginning of an existing list, at the middle of an existing list, which means there's something before and after, and then finally at the end of the existing list, which would be after what is currently there. Okay, I panicked for a second on which finger I was stretching. I was like, oh no, I'm doing insults, but okay. So yeah, all right, so we'll do that by saying something like, maybe like let's insert a G, and then let's try inserting something at the beginning of the linked list, or actually at the end. Let's do the end first. So maybe we'll do like something after G, which would be T. And then maybe we can test by inserting something at the beginning of the linked list, which would be like a C. And then something in the middle, so maybe like something between the G and T. So maybe like an M. And then something that might be good to check when we're doing something sorted is if it works with duplicates. So maybe insert another G in there. And then after that, let's test the delete. So maybe call delete on maybe one of the G's. So that'll be another thing we got to figure out. When we say delete G, we can choose to either delete one of the G's or delete all instances of G. So, you know, we can actually do 2 functions that do that. That might be a cool thing to do. So let's create another function called delete all. And that will basically delete all instances of it. So this will delete all instances of that letter, all duplicates. And then this one will delete only first instance found. Okay? And then that. If you inserted all the letters of the ghost, it will be in alphabetical order and spell ghost. That's cool. We should do that. O-S-T, but right now it won't because there's other letters around it, so we will have to delete like the M. So we can test the delete all with the G. Actually, to make sure that it both work, let's insert one more G. Then let's call delete G first to see if it deletes that one G, and then we call delete all on G's and see if it deletes the other 2 G's, and then we can go ahead and insert the G again. Okay, so I think that is enough testing for that. Of course, we do want to have a print function. We'll have a lot of prints in between. Oh, we still got to do the search. Okay, let's just put a search for, I don't know, the H. Okay, so that one we have to see out. Since it's a valid returning function, it's just going to return the index. So yeah. Okay, and then we're going to put a bunch of prints maybe after all the inserts happen. And then after there's the first delete, so we can see what happens. And after the delete all, so we can see what happens. And then after all the inserts, which we have already printed. So, okay. And then finally the destructor, which will run automatically. So, yep, that is all good. Okay, so now we have all test cases. If we run it right now, it's gonna run, but it's not gonna print anything. It might just print like an invalid. It's gonna give us a warning for this. So here, let's just return -1 for now, for the valid returning function. And then, oh, we forgot some semicolons on the prints. Okay, so if we run it right now, it's just not gonna print. It's gonna print like -1 at some point, and that's it. But as you can see, no prints are printing anything because there's nothing in the list. In fact, we could probably do a thing on the print function that says something like if list is empty, so like if head is equal to null, we can say something like cout list is empty, period. And then we don't need the return, but we're going to put it anyways. So now we have a bunch of lists is empty. Okay, so that looks nicer. All right, maybe exclamation point instead of a period because we were very emotional. Like, yes. All right, so let's go ahead and do the insert first because we can't really test the delete or the search if we don't have anything in the list. So what I'm going to do first is I am going to write some comments of what I want to do. And then I will replace those comments by code. It's a good approach of how to figure this out so we kind of troubleshoot before we even start coding it. So what we want to do first is we want to check if list is empty. That's one of the cases. If so, then just, you know, insert and make head and tail point to it. So that's the first case, right? We want to insert, if we have head is equal to null, then all we got to do is literally just like throw in the node and then make head and tail bullet point to it. Done. Okay. Make sure we return to that. Other cases is list is an empty. So that one, those are more interesting. So we have basically 3 cases, which is insert at start, insert at middle, insert at end. Right? And so for those, it's going to depend on where the item is going to be inserted. So this whole thing, these 3 comments basically, should be in a loop. So we're going to loop through the list to find where to insert, right? We got to loop around basically to traverse the existing linked list to see where in the linked list our letter is supposed to go, so it's alphabetical. Okay, so for doing that, we can just use the while loop that we use for printing, but we can just check to see if the letter that we're looking for is less than the letter that we're looking at. If that is the case, then we want to insert. But if the letter that we're looking for is greater than the one we're looking at, then we want to keep checking, right? So let's kind of write that down. So if the letter that we are looking for is less than, or here, let's start with the written part, is greater than the letter we are looking at, it must go after it. So keep searching. If the letter that we are looking at is less than the letter, oh, I wrote this twice. If the letter we are looking for is greater than the letter we are inserting. If the letter is, I was thinking it right in my head, but I didn't write it right. So let me make sure I wrote this right. If the letter we are looking for is greater than the letter that we are inserting, we are looking at. That's what I would say. If the letter that we are looking at, that we're comparing with, is greater than the letter that we are inserting, it must go in it. In this case, it must go before it. Okay? So let me put that one beneath. Okay. If the letter that we are looking at is less than the letter that we are inserting, you know, it must go after it. So keep searching, okay? So let me make sure that we understand what is happening here by maybe doing some pictures. Okay? So what I'm saying with this is that, let me get a piece of this linked list. Same thing we've been doing before, but you know, it's a good reminder. So what I'm saying with this is that let's say that I am looking at the following mixture of letters, okay? So maybe we have the ghost thing. So we have G-H-O-S, okay? And I'm trying to insert a M, okay? So we know the M's gonna go right here, but let's think about what that means. What that means is that if we're looking at a G right now, which is the first thing on the list, and G is less than M, then what we can guarantee is that the M has to go anywhere here. But it cannot go before, because that would break the alphabetical. However, if the letter that we were looking for was less than, I suppose, or equal to the letter that we're looking at, so if the letter was anywhere from A to G, then it has to go before the G. Well, the G could go after because it's equals, but let's just say it has to go before. It has to go before because otherwise it would not be correct, right? So that is what we're taking advantage of, to know that we have to keep looking. Because if what we're looking at is bigger than, it could be anywhere after. But if what we're looking at is smaller than, it has to go before. So what do we do next? We go ahead and we look at the H, right? So when we're looking at the H, we know that the M is bigger than the H, so we have to keep searching. So in that case, what we can guarantee is that the letter M has to be inserted after the H. We don't know if it's right next to it because we don't know what's after the H. There could be like a L or something, but it has to go after, not before. Okay, so then we look at the O. So now the O is bigger alphabetically than the M. So now we cannot put it after. We are guaranteeing that it cannot go after, it has to go before. So it has to go on this side. So that means that it has to go in between the last letter we looked at, because the last letter was bigger and this one's smaller than. So the last letter was smaller and this is bigger than, so it means it has to go right there. So that's basically how we identify the location in code, okay? So that's how we get this. And yeah, that's pretty much a good layout of what we want to do for the function. So make sure, I guess, the thing that once we finish inserting, return afterwards. Otherwise, we will break things. We did that the other day, I think. Okay? So, yes. All right. So let's just start coding. We can leave the comments in. I mean, hey, we have the free documentation. And now, just code beneath what each thing does. So the first thing that we didn't write in the comments, what we should do is basically create the node that we're going to insert. So we can do that by saying node car and then calling it like curve, or actually not curve, but what did we call it? Oh, just temp. I think we called them temps, the ones that we want to insert, right? So I want to be consistent on my naming convention. What did we call them? Let's see. Let's insert, yeah, we just call them temp. Okay, so we'll be consistent and call them temp. So we will say new node var has the value of var in it, okay? So we created a brand new node, and now we're gonna go ahead and insert it. So first of all, we wanna check if the list is empty. So we can do that by saying if head is equal to null, then we know it's empty. At which point, then we can just insert it. So we can say head and tail are both equal to temp. So what this line of code is doing is the same thing if I said this. Head is equal to temp and tail is equal to temp. I'm just shorthanding it for that, okay? Why do I want both pointers to do that? Because that's kind of what it should look like if it's a single item in the linked list, right? So if you have just one thing in it, so right now, if the list is empty, we have head and tail just kind of pointing to null each, okay? But now we're inserting one node into the linked list, which the next in the prior pointing to null, but now we have some letter in there, okay? So what we want to do is we want to update the head and the tail pointer to point both to this node, okay? So that's what we're doing with that line of code. All right. So after that, we're done. So just return, get out, you know, don't break other code, right? Okay. We could do an if-else statement too, but I don't want to have to tap my code a lot. So we'll do some spaghetti. All right. So, okay, that takes care of that. So now we can go ahead and do our loop thing. So let us go ahead and do that. So we can say while, well, let's make a cur pointer first so that we can use that to essentially, you know, track the linked list without breaking the tail pointer, or the head pointer. And in this scenario, we can go ahead and start our loop. So we can say while cur is not equal to null. What does it mean if it's equal to null? That means we screwed up at this point, because we should never fall out of this thing. Like, if we get it to null, bad things have happened at that point. So yeah, but still, we'll leave that in there so we don't avoid crashing, okay? We should never have that cur be basically null at this point. So now that we're looping, at the end of the loop, yeah, we can say something like cur gets cur next. But before that, we want to do our if statement check. So we want to say if cur is less than, so I'm literally looking at this line of code. So in fact, here, let me move that code. First of all, let me split it because it's really wide. So split it like that. And then just take that and then basically put it here. So, okay. So we can say something like if the letter we're looking at, which is cur, is less than the letter that we're interested in, which would be at, so this is cur data actually. If cur data is less than temp data, which is the one that we're trying to insert, and cur is the one that we're looking at. So if the one we're looking at is less than the letter that we are inserting, less than or yeah, just less than, not less than or equal to. Then keep searching. So now we just keep searching, okay? So really, we can go ahead and just kind of throw in the cur next in there and we're done. Otherwise, what that means, this otherwise, is this comment here. So let's just move that. If the letter that we're looking at is greater than or equal, and then let me put this in 2 lines again. It bothers me this is not lined up. Okay. So what we're saying is, if it's not what we're looking for, if we gotta keep going, then just keep going. We're done. Otherwise, we have basically found where it has to go. It means that cur is like one too far. Like it needs to go right before. So we need to insert it before it. Okay. So at this point, insert it before cur. Okay. That's what we got to do right there. So all our code is going to happen there. But after we're done with it, just get out of the loop at that point. In fact, don't just get out of the loop, but literally like return out. Just be done. Spaghetti it more. Okay. So insert it before cur. Okay. So here's the thing though. We still sort of need to identify if we are facing any of these scenarios. Okay. Because we could be facing any of the 3 scenarios. So the way that we can identify that is we can see that if what we're inserting, which is cur, if that is equal to head, then this means that we have to insert it at the beginning, right? Because if we have to insert it before the head, it means it's the first thing of the list, or it's going to be the first thing of the list now. So that's how we can check that part right there. Alternatively, we can check if it's in the middle by checking the tail pointer. So we can say something like if cur is equal to tail pointer, then that means that we're inserting it right before the end. Or sorry, or actually, no. Okay. So if current x is equal to null, yes. Actually, that will work better. So if current x is equal to null, we don't need to use a tail pointer for this. Yeah. Because if it has to go after, then but then this might not. Okay, so we might have to put this somewhere else. Yes. So we are going to move this out of this loop. Okay, it'll make it easier. Like that. Because here's the thing. We can say that if the next thing that we're going to insert is equal to null, that is the sign that that this needs to go after. Okay? So we could do it here, or we could just do it outside the loop. So I'm actually going to move it outside of the loop just so that it does not look so messy. So we're going to put it here. Okay? Yeah, so this will actually work out better. So what's going to happen is, if this ever gets out of the loop as it is now, then that means that that the letter that we were looking for was greater than the last letter. Okay? So it means that that it has to go at the end. So then we can just do that at the end here. Okay? So this will work out pretty well. If the letter that we're looking for is greater than or equal to the letter that we're inserting, it must go before it. Yep. Okay, because it will never be greater than. Okay, perfect. Yeah. Okay. So let's go ahead and add that in right now. So to insert at the end, what we need to do is cur is equal to null at this point, so it's useless. Like, we can't use that. But we have tail. So what we can do is we can say tail next is going to get the new node that we're inserting. And then we need to update that new node's previous pointer to point to what tail is pointing to. So we can say temp previous to point to tail. So we're basically doing that. And then once we do that, we have updated both pointers that need to be updated. So we just have to update the tail pointer itself to point to basically the new node. Like that. Okay? This would alternatively work if you wrote tail gets tail next. But there's no need to do that fanciness because we can just use temp. Okay? So that should work for inserting at the end. So now all we gotta do is insert. Actually, we still gotta finish doing the insert at the start and then insert in the middle part. So I'm trying to see if we can make the code prettier, but we might refactor the code to make it look prettier later. Okay, so this is what we're looking at right now. There, at least the comments now match. So we have a while loop that is looking through the entire thing. If we look through, and what we're looking for is we're trying to find a letter that's bigger than what we have. If we do find something like that, then that is a good sign. That means that that it goes before it. But if we don't find a letter that's bigger than us, and we finish looking through the entire loop, we hit the road end sign, it means that it has to go at the end. That's when this code's gonna run. So this code's gonna run like that, and then it'll put it at the end. So we have that taken care of. If the list is empty, then that is not an issue because we have already taken care of that up here. So what we gotta do is just do the insert at the start, and when we finish inserting at the start, we wanna make sure that we return. When we finish inserting at the middle, we want to make sure we return. So that's why I put the return outside of both instead of copying and pasting it. But it could also go inside of the else if. We could also combine this else with this else if, and then this else if like that. But I'm going to leave it like that because it's a little easier to visualize. Okay? So let's go ahead and insert at the start. To insert at the start, what we need to do is we need to put it in between. We need to put it before the head pointer. So what we're going to do is right now, the head previous is this node, and that's pointing to null. So instead of pointing to null, we're going to make it point to the temporary node. And in the temporary node, both pointers are pointing to null. We're gonna leave the temp previous to point to null because that's a new beginning. We want the temp next to point to the old head so that it's linked to the second one. So if you want to see a picture of that, what I'm doing is this. I got let me just copy and paste a piece of this list. So I got myself the following thing, okay? And I'm inserting at the beginning of it. So if I'm inserting at the beginning of it, here is the procedures that I need to do, okay? So I got myself the node, this is temp. What I need to do is I need to first update this pointer like that, and then update this pointer like that, okay? So to do, let's call this pointer 1 and pointer 2, okay? The two arrows, okay? To do 1, what I have to do is I have to first of all see what it's called. So that is called hprep, right? Because that is basically this right here, hprep. So I need to update that to whatever this is called, which is temp. So I can literally just do hprep gets temp. Okay, so that's where that is coming from. And then the second one is I need to update temp next. Temp next is this pointer here. So I need to update that to basically point to this first old node. What is pointing to that node currently? Head is pointing to that node currently, see? Head is pointing there. So all I gotta do is just make htemp, where do I put this up space? I'll put it htemp is equal to head. So that is how I basically got those two lines that I have in the code right there. Okay? So, yes. So nobody's asking, so I'm assuming that some of you might be confused. So the color coding is useful. Let's do purple, okay? And then for the tail pointer, might as well do the coloring as well for that one. For the tail pointer one, for this one, lines 63 to 65, that was the equivalent of inserting at the end of the list. So let me see. I'm happy that I made a pretty version of the linked list because now I can just keep recycling that. So we don't really need to see the beginning of it. So let's just say that it's just an ongoing linked list, and then at the end of it, we have this. Okay. So what we want to do is we want to insert our new node. Our new node is called temp, which means that again this is this is temp next and this is temp prep. So what we need to do is we need to make this not point to null anymore. We need to make that point to this. Okay. Visually, what that looks like is more like this. Okay, but that's okay. So that's 1. So we'll call that 1. And then the other thing we need to do is, because it's a double linked list, is we need to make this point back to that node. So we'll call that one 2, okay? So the code for 1 and 2 is going to basically be T next, which happens to be this pointer right here, or TN I suppose. We're gonna make that point to the new node, temp, which is where that's coming from. So that you can see that tail next temp, line 63. That's the number 1. The number 2 is currently this previous pointer. So that is just called temp, P next. So temp prep. I'll just put it P because I'm running out of space here. Temp prep is this pointer right here. We want to make that equal to, let me move the T because it's like on my way. So let me just put the T like that. So I have space to write, okay? So we want that pointer to point to T. Oh, well, look at that. I should have just left it. It's just equal to T. So that worked actually. Okay, that's funny. That whole thing is T essentially. Okay, so we're doing that. However, at the end of this, I didn't do that in the beginning too. Oh snap! See, this is good. We do this because I forgot one thing to do. But after this, the third step for this is that we want to update T because T is no longer this last one. So T is now going to be updated to point to the new T, which is this one up here, which is the T's always pointing to the last thing. So this is done by updating T to be equal to temp, which is how I got line 65. But now going back to the other example with the insertion at the beginning, I forgot to do that, right? Yeah, I'll update head to temp. You're correct indeed. So because right now head is still pointing to the second thing of the list, but I need to make sure that that points there now. So yes, you will achieve that by doing head is equal to, I put an arrow instead of an equal sign. Head gets temp. What colors were these? I don't even know. I think this was this color. No, it's not that color. Maybe this color? Yeah, there you go. So that's that color. And then the green was, I think. There's like 4 different greens here, so. Close enough. All right. So, yeah. So see? Drawing it actually helped us because we would have forgotten that line of code. Bad things would have happened. Like we would have never been able to insert at the beginning. Like the whole insertion thing would have been messed up. So yes, always when you're inserting at the beginning or the end, make sure you update your head pointer or your toe pointer, depending on what you're inserting. Unless you're inserting flat out in an empty list, in which case you update both, which is why I have this line up here. Okay? So pictures are good. In fact, let's just kind of keep going with the picture theme for the middle one. Okay, so for the middle one, let me yet again copy a piece of this linked list. So we got ourselves some linked list that's happening here, and it just kind of keeps going. The point is that we're inserting somewhere in the middle of it. Okay? So we're just kind of inserting in a linked list right there. And where we want to insert, is right here. Oops. You want to insert right in between those two, okay? So we'll call this next, previous, and this is called temp, okay? So remember the way we have the thing with the cur is that cur is going to be pointing to, if the letter we are looking at is greater than or equal to the letter we are inserting, it must go before. So we're pointing to this. So in this case, we will be pointing to the one after we want to insert. Okay. So even though we want to insert right before it, that's what's going to take us to line 58 in the code. Okay. So because of that, we need to put it in between. So this is where you got to be careful the order you do things. Otherwise, you break the whole thing. So to do this, what I'm first going to do is I'm going to visually separate it a little bit so I have some space to work with. So we're going to kind of move it like that. And then for now, let's leave the arrows be as they were, but just longer. So that's pointing right now there, and that is pointing there right now, okay? So that's what we got right now. So what I want to do is before I modify these two, before I change those, I want to make sure that I first link these. So first link that and then change those, okay? So start by copying this value here. We want to copy that into this one, okay? So we want to make sure we want to do that copying. The way we're going to do that copying is we are going to say cur prep. What is cur prep? Cur prep would be this one right here. It would be that node. But we want not just cur prep, but we want the next component of that. So we're going to say cur prep next. Okay? So cur prep next Yeah, I know that's weird, but that's just the way it is. Cur prep next is equal to, oh, sorry. We want to update, sorry, my bad. We want to get this value of cur prep next. We don't want to make it equal to anything. We want to copy it into something, okay? So we want to, hold on, it's like stuck. There we go. This right here is the green arrow, okay? So this right here is the green arrow. We want to save that into the red one. The red one is found at temp next, right? That's the red one. So what we want to do is we want to assign it. So basically there. I'm going to shrink it so you can see the whole line of code. Okay? Like that. That is going to basically make that arrow point to there. Okay? So that takes care of that arrow. Next thing we're going to do is we want to copy the content of this arrow. We want to copy that into this value here. So temp preb is that value. We want to assign that. We want to assign what is in the orange one, which is going to be cur preb. Okay? Cur preb is going to copy that. By doing that, we are now making this link to that. Okay? So the linked list is now connected properly, in at least with the new node. Now what we need to do is we need to update the green and orange pointers to link to the new node. So the next thing we need to do is we need to update the green pointer. So that is going to be this right here. We want to update that to point to our new node. In other words, we want to take this arrow, we want to erase it, and then we want it to point here. Okay? I know, it is pretty cool. It just takes a lot of effort to kind of get it right. This looks like a French flag. Okay. All right, so that we want to update that green arrow to be that. So how do we do that? Well, let's color code the word temp, I suppose. Might as well, since we're going hardcore with this. So what we just do is put temp. Okay, that will basically make it point to that. Similarly, we also want to assign something else to temp, and that is the orange one. We want the orange one. We want to erase that. We want it to point there. So what do we do? Well, we have it right here. So just literally take that and put it there. And there you go. All that color coding, yes, for those 4 lines of code. So let's just literally copy and paste those 4 lines of code and we're done. So that is temp next equals to cur preb next, and then temp preb is equal to cur preb, and then cur preb next is equal to temp, and then cur preb is equal to temp as well. Okay, and that's it. We're done. We're done with the insert function now. That's the third case. That's a hard one, right? Because we got to deal with 4 pointers now. Before, you were only dealing with 2 pointers with a single linked list, but twice the links, double the segfolds. So yeah, okay. We have not done the delete function, but that's okay. We are just going to run it and see what happens. Oh, yeah, I forgot the bars and things there. So line 30, we'll do that. Here. So. Ooh, that's not good here. We need to change something so like we'll call it data or something. Or just D for data. That. Why did I do that? Okay. All right. We're just naming convention issues. Let me kill the colors. Okay. I have no idea why I picked that. It must be a variable name for something. Okay. So let's see if this works, at least for the insert. So let me put side by side here. And so we got the G is inserted. And then the T, we should probably add print statements as well. Okay, let's just see if it inserted. But we could add print statements to see how the list grows. But the point is that it inserted a G, a T, a C, an M, and 2 Gs. And as you can see here, then we call the print function. It worked. It has a C in the front. It has the 3 Gs. Then it has the M and it has a T. So it worked. It worked. Of course, the deletes don't work because we haven't coded them. So when we call print again, it's just printing it out again. Here, we should probably add an end line to the print function. Like at the end of it. And then add an end line here. That way it'll look a little bit easier to separate the different print commands. Okay, so because the delete doesn't work, these two look the same. I do want you to notice something. Look at how the pointer things work. So like the first pointer's, the previous pointer's to null, and then the last pointer's next pointer is null. That's good. That's what we expect. But notice that the next pointer here, you know, is basically where this G's at. So the previous pointer of that is where the C's at. So it's easier to see here. So like you can see that this G, this address here of the like the previous address here is also going to be the address of the C next. See that? So like I can't highlight both at the same time, but I'm losing the mouse. So like, look how this address right here is the same as this address, right? Because the predecessor of G is this G right here, and the successor of C is this G, right? So the next pointer of this is the previous pointer of this. So that is why this address and this address is the same, which is pretty cool. Or like, for example, let's look at these 3 letters here. So this G, the letter after the G is the M, right? So if we want to print out where the address is, we can see that it's also the previous address here of this. So that's what this is, right? We could do something like, we could use a this pointer to print out like our address. We might be able to do that really fast, so you can see this a little bit better. We might go over like 10 minutes so that we don't have class on Wednesday. So we can say like our address. And for that, we can just say this. Okay, so now you can see that we can see our address. Our address is where we are at. So you can see that when we say the next of this is matching the address of the G, and then this next is matching this address, and then like for example this one is matching this one. So you can see that it'll work. Or the previous ones, let's see. The previous one of the T is the M, which as you can see these 2 addresses match. Or for example, the previous of this G is this one, so you can see the addresses match. So it is happening. I mean, it's cool. It does happen to be that this is all nicely lined up just because we declared in that order. No guarantees this is always the case. No guarantees. This could be all over the place. These addresses could be like literally all over the place in any mixing order. So that, which is why you can't access a linked list quickly. Okay, it's just because we inserted things in this order nicely that it looks like this. But it probably started to get messed up later on. What's the difference between making a node a class versus a struct? So that's just there's no difference. So a class and a struct are the same in C++. The only difference between them is that a class by default is private and a struct by default is public. So like I just made it public right there. So by doing this, I might as well just written the word struct. But struct is like, it's like a remainder from the C days. So that's why the word struct is still there, but it's not really C++. So that's why we don't really use it often. But I could have just written struct there and not written the word public. That would have been the exact same code. The compiler treats it the same way. Anyways, here is us inserting more things. It's still alphabetical. As you can see there, there's your ghost. We just don't have the delete function yet. So we still need to do delete. The search we can do very fast. I can just copy and paste the code. Oh, I gotta move the microphone a little bit. It's like blocking. The search we can do by just copying and pasting this search actually. So I'm just gonna copy and paste it. So we got, oh, we made a recursive search. Oh, let's not do a recursive search. I can just code it. So we can say while, so let's make a temporary pointer, node var cur, and then while cur is not equal to null, and then keep a counter. So like int c is equal to 0, c++ cur equals cur next. So then if the node that we're looking at, so cur data, if that is equal to bar, well not bar, let's see d for what we're looking for. If that is equal, then we can just go ahead and return C. Alternatively, we just keep going. And if when we get out, if we're still in the code, then we can just say return -1, which is not found. And then if we do that really fast, I think that should be good enough. C++. Expected semicolon. Oh, I put a colon. Okay, weird. As we can see, it did not find the H. Oh, why? I should have found this. There is H's in there. Well, cur is not equal to null. Cur data equals to D. Return C. Yeah, I thought that too for a second, and I was questioning life. But then I was like, nah, no way. Oh, it's returning C. No, but that's okay that it does that. Is it like the first letter in here? What happened? Oh, wait, maybe we just haven't inserted an H at that point. No, we did insert an H for sure. We have definitely inserted an H, but it still says this is -1. Barker. Oh, I know why. We never set this. Sorry, my bad. We gotta set this to the head, so it starts searching in the actual list. Right now, it's searching in like nothing. In fact, surprised it didn't crash actually. Okay, so now it says 5. So is that actually up 5? Let's see, 0, 1, 2, 3, 4, 5. So yeah, it worked now. Okay, so that's why we didn't actually set the head pointer like to the cur. So like this was just like some garbage value that was just being declared, and then that garbage value was luckily enough being set to null, because if it wasn't, then this line of code would have segfaulted it. So we got lucky that it didn't segfault and make us waste more time. So that's how you would do the search function. You could also do the exact same code. We did the recursive version of it. The only difference in this code that you have to change is literally nothing, actually. Nothing. I think nothing. Maybe just here, put the word bar, and then, yeah, this would work the exact same way. So you can try it out if you would like, by copying and pasting it and playing with it. It should work the same way. Finally, for the delete. So the delete is actually not something that I could probably achieve in 5 minutes, because we have to deal with multiple cases with the delete. So yeah, we have to do the 4 cases for the delete as well. So what we'll do for that is well, we have 2 options. I can either do it on Wednesday, or I can do it now and then not have class on Wednesday. But it is going to take me maybe like 15 minutes to do that. So what we'll do is this. If you have another class, you can go. I mean, well, you don't have to watch anytime anyways. But if you have another class, then you can go. If you want to stay and watch it, you can. Otherwise, you can just watch it on YouTube at some point between now and next Monday. But I'll go ahead and just do it now. That way we just wrap up linked list, and then we don't have to have official class on Wednesday, because it shouldn't take us that long. And also, I'll try to do it quickly, but we'll see. It's basically the reverse of the insert. Okay, so yeah, we'll just do that. So it's up to, I mean, you guys don't have to stay, but I'll just go ahead and do it now so we can make it all in one nice video. Okay, so for the delete, it's really 4 cases that you have to consider. Again, you have to search again to find the item you're deleting. We know how to do that. I mean, we just coded a search function, so we could actually use a search function to delete, but we'll just we'll use the same code. And then once we find it, then we mess with pointers depending on where it's at. So the first thing we're gonna do is go to the spot we want to delete. And what we're going to do the normal delete, and then doing the delete all is very easy. We'll just do a slightly tweak. It'll take us like 30 seconds to do that. It's just a little loop. But yeah, so we want to go to the spot. So the way we're going to go to the spot is we're going to use the same thing that we did before. So we're actually going to copy and paste from the search, the pointer, the curve pointer, and then we're going to copy and paste the loop without the counter, but we will have the loop in there as well. So while cur is not equal to null, if cur is equal to d, okay? So this right here. Okay? So when it's equal to d, this means delete cur. That's what we basically have to do. Right there is where we got to delete. When we find the letter, okay? If we get out of this loop, it means we didn't find it. So we can actually return something like saying nothing found to delete. Or maybe more descriptive, did not find, and then d, we want to add the variable, did not find d to delete. Okay, so that's basically saying could not delete anything. All right, so now that we found it, we need to identify the 4 scenarios. Okay, so the 4 scenarios for deleting are 3 of them are for, so 3 of them are going to be is it 4? It's kind of like 4, it's like 3.5 really. Okay, so the 3 delete scenarios are delete at start, so first item, delete in middle, delete last item in list, as in like ordering. But there's a special sort of scenario, special case, where we are deleting the only item in the list. Okay, so that's a special case, which means it'll be empty after. And there's also another sort of special case, which is that the list is completely empty. But that is already taken care of, because when we say cur equal to, because we are assigning head to be cur, if the head is equal to null, this loop will never enter, which will just say did not delete. So that's another scenario, but it's already kind of taken care of, okay? Which is like there's nothing in the list to delete, so nothing. I could have written that as a separate if statement, but again, it will never enter the while loop, because if the list is empty, head is empty. So head is null, which means if head is null, then cur is going to be null, which means that cur is null, so it doesn't enter the loop, so it'll just say it did not find. Okay, so that's why it's like kind of like 3 3.75 kind of thing. Okay. So delete at start, delete in the middle, delete at end. So the way that we are going to identify if we're in any of these scenarios is by checking if the cur node is equal to the head or to the tail. That's how we're going to know if it's in the beginning or the end. And if the head and tail are equal to each other, that's how we know that it's a weird special case, okay? So let's just kind of go with each of those. So if head is equal to cur, and again, cur is what we're deleting at this point. So if head is equal to cur, that means that we are deleting the first thing. And because that is the case, what ends up happening is we need to update the head pointer after we finish deleting. Okay? So update head pointer after deleting. All right? The other scenario is tail is equal to cur. Okay? If tail is equal to cur, that means that we are deleting the last item in the list. Okay? If that's the case, then what we need to do is we need to update the tail pointer after deleting. And this is the same for a singly linked list with a tail pointer than the double linked list with a tail pointer, by the way. You have to update the tail pointer in this scenario. Okay? Finally, the other scenario here would be to delete in the middle. So do not need to worry about head and tail. Here's the thing. This special case up here that we're still to do, we can actually do that one as the first one. So the way we can check that is we can say if head is equal to tail, which is equal to cur, but we need to split this into two if statements. But if we want to do if head is equal to cur and tail is equal to cur, then this is a special case where we're deleting the only item in the list. So we'll put that in like that. Okay? And that's it. Since we did it if else if, then we don't really need to do anything else other than put a return here. Now here's the trick. When we finish this code, if we want to delete all duplicates, all we gotta do is literally remove this return in this version of the code, and then it should delete all the duplicates. But for now, we're gonna leave it in there because we do not want to delete duplicates, okay? That's why I say it's gonna take like 10 seconds to do it, if we do it right. Okay. So let's start by doing the easy one. The easy one is like head and tail. It's the one thing to delete, so we just delete it and then we're done. So we can do that by just literally just doing delete cur, and then after that we want to update head and tail to be equal to null because the list is now empty. Okay, so that's that special case where there's only one thing in the linked list. We delete it, so now we just kind of set them to pointers to be to null so that we can indicate that the list is currently empty. If we don't do that, then the thing will break. So we want to make sure we update it. Okay, so that means we're pretty much done with that case. Moving on to the next case is going to be to delete at the beginning. So for deleting to the beginning, what we need to do is we want to update the head pointer and then we want to delete. But we are going to need a temporary pointer, but we have the cur pointer, so I think we can get away with using just the cur pointer. So what we want to do is we're going to say cur next is going to be, for this we're going to have to use pictures because otherwise you guys are going to get confused and I will get confused too. So this is what we're looking at right now. And we're trying to delete that first node, okay? So because we're deleting that first node, what we want to do is we want to update the head to point there. And then we want to update this previous pointer that's pointing there. We want to update that to null. So that would mean head next or cur next, which I'm going to use cur next because that's going to extrapolate to the other scenarios. So cur next. Preb is the orange pointer, okay? Because cur next means basically cur next preb, okay? So cur next prep, we want to set this to null. Okay? That is going to basically cut this link and set it to null. Okay? Once we do that, then we can go ahead and just wipe this out from existence. And again, make sure that we update the head pointer to point to the next node. Okay? And don't forget that all this thing is being pointed at by cur. So the way we're going to do that is we are going to say cur next prev is going to be equal to null. So that takes care of cutting out the orange pointer. And then from there, we want to say delete cur. But before we do that, we want to make sure we update the head first. Otherwise, we're accessing a dangling pointer. So we're going to say head is equal to cur next. That's going to update the head to point to the second node, which is a longer arrow here. Okay? So once we do that, we've set the pointer to null. We can just get rid of that, and we're in business. So yes, delete cur. Okay, we're done with that. Moving on, we're going to skip the middle one again because that's the tricky one. So we're going to do the last item one. So the last item one is kind of like the opposite of this. So that one is, for example, if we were deleting this last node. Okay, so cur is currently pointing to the node that we're going to delete, and so is tail technically. So what we're going to do for this is we need to set some color. We need to set this pointer to be to null so we can cut off that link. How do we get to that pointer? Well, we can use the previous pointer here to go here and then go to the pink, to go to the blue one. So that would be cur previous. That gets us to the node before it, and then we just update the next pointer of that. So we want to set that to null. That is going to basically cut off this link and set this to null, just because it's going to be the last new node. Once we do that, we are safe to delete this. But before we do that, we want to make sure we want to update the tail pointer so that it's not pointing there anymore, but instead pointing here. Okay? Move this so it doesn't get confused. Okay? So how do we do that? We can just say cur prev, which is pointing to the previous node, is what we want to set tail to. Okay, so tail gets previous node. All right, so once we do that, then we can just go ahead and delete cur, which is the red stuff. Okay, so that ends up being cur prev next gets null. So that cuts off the pointer from the last node to the second to last. And then, oh sorry, that cuts up the pointer from the second to the last node, so the blue one. So that cuts up the blue one. I didn't highlight it. So that's the blue one. So that cuts off that one. And then the green one is this one. So we want to update the tail to point to the second to last item because that's the new last item. Like that. And then we can just go ahead and delete cur. Okay? So that takes care of that scenario. All right, one left. The middle one. That's a tricky one, but you know, not to worry. We'll be okay. All right, so for that one, let me just get this much. So let us say that we're going to delete, yeah, let's put it like that. And then, okay, so, all right. So we're going to delete this one. Okay, it's just some random node in the middle of this thing. All right, and so it's pointing to it right now. So what we need to do for this is we need to update two pointers, okay? We're going to call this the green pointer, and then we're going to call this the blue, purple pointer, okay? Those pointers right now are pointing this way and this way, okay? What we need to do is we need to make them point here, and then we need to make this one point here, okay? That is the end game that we want to do. Once we update those 2 pointers, then we can go ahead and just delete that, okay? So let us first of all get the green and blue pointer. So the green and blue pointer using cur can be accessed by saying cur preb, that gets us to the node before, and cur next gets us to the node after. But we need to get to a specific pointer there. So that is going to be the next pointer for that one and the prep pointer for that one. So if I color code this, what this looks like is essentially, oh, that's not the right green. This one and this one, okay? So that is how we get to the green and how do we get to the purple one. So what we need to do though is we need to update them. So how we're going to update them, I have to shrink this because we are going to need more code, is right now they're pointing to cur, but we wanted to point to the one after cur. So this next pointer needs to point to this node here, and that node there is located at cur next. So that's basically how we get cur next there, okay? So cur next is this node, and cur, here, let me write it here and I'll shrink it. Cur prep. Shrink, okay. And maybe shrink this too. Okay, so oh, that error looked nasty. Okay, so now we can say this is cur prep, which is this right here, and then this is cur next, which is this right here. Okay, so we are saying to take the green arrow and make it point to the orange arrow, which is cur prep next gets cur next. And then we want to take the purple arrow and we want it to point to the yellow arrow. So all we got to do is basically take this address here. So take this address and put it there. Okay, so that'll basically do the correct pointer stuff. Okay, so from there we just need to delete cur. And then we're good to go. That's it. So that's actually not bad. I said it was going to be harder. It is harder conceptually because, as you can see, there's a lot of arrows and curs and necks and curs and necks and preps. But it's less code than the other two because we don't have to update any title head pointer. So this is a scenario where less code is not necessarily easier code. So yes, we will soon have the ghost. Prep next gets cur next, and then cur next prep gets cur prep, and then finally delete cur. And that's it. I think we are good to go now. Yeah, all right. So fingers crossed that everything goes well. Let's see if it compiles. All right, it compiles. So let me first hide this. Okay, and then let's go to move this and run it. Okay, so let's see if it worked. So we got our CGGGMT, which we know is okay, but then we called delete on one of the G's. As you can see, one of the G's is indeed deleted, so that indeed worked. The delete worked. Now, the delete all G's is not working because we haven't coded that, but let's just go ahead and do that. So again, that is literally going to be copying and pasting the same function we have. So take this function, copy and paste it here, but then remove the return statement. And replace it with, once we do that, then replace it with, we want to replace it with cur next at this point. It's okay, not to worry. We can make a backup pointer so that we can update it with the next thing on the list here, which is actually... So in all scenarios where we deleted it... what the heck, I know how to make it easy. Let's just set cur at this point to be head. And then it's not efficient, but it'll work. It'll just reset it to start searching from the beginning again. Okay? Yeah, okay, that should work. D was not the corner of the scope. Oh, I need to put the D here. There's a more efficient way of doing that, but, you know, that's the quick way of doing it, okay? So, by doing that, again, it's the same code. All I'm doing is instead of returning, I'm resetting the function, essentially, so that it searches again for more stuff. So, as you can see here, when we call delete G, there's 2 G's left. But then, I call delete all G's again, and it deletes all G's. That's funny. It actually says to not find any G's to delete because after the last reset, it doesn't find any. So that's why it says that. That's okay. We could just remove that comment, but that's why it says that actually. So then, anyways, we end up with just CMT. H is at 2. Is that true? Yes, H is at 2 indeed. And as you can see, we got a bunch of other letters, but we can get rid of them so that we can have ghost. So we need to delete a C and an M and a T. CMT. So let's use this for 2 of them. So let's use this for the C. Let's use this for the M. And then let's use the normal delete for the T so that we don't lose the other T. So yes, in theory, we should have ghost. So, ooh, this would have been good for a Halloween theme, but that's okay. So yeah, there you go. The delete works now. So just to kind of refresh on what we did is we look for the 4 spots to delete from, which is beginning, middle, end, and then the special scenarios, which is deleting the only thing in the list, which makes the list be empty, and then the other scenario, which is that you delete one thing in the list, or sorry, you're trying to, I guess, delete something, but the list is completely empty. That's the other scenario. Okay. So to make it delete duplicates, what we did is we basically reset it. So after it deletes one thing, it resets it to the head so that it starts searching again for more things until it just can't find any more. A more efficient way of doing this is to have it search from the node before cur, which I could have done if I make a backup of cur before playing with the pointer. Which I'll leave that to an exercise to you. But all you gotta do is make another pointer, call it cur2, and then before you start doing any of the deleting, back up cur1 by just saying cur2 gets cur, and then set cur to be cur2. And then if you do that, it'll be more efficient. And the way you can check if it's efficient is write a cout statement in your while loop, so you can see how many times the while loop is running, and you'll see that it'll run less times because I have to start from the beginning of the list. Here you can't really see it because it's such a short program, but this would be the most inefficient way of doing it. But as you can see, it was very fast to code. So this is what a Doubly linked list is, and most of the class was actually more focused on just showing you how to do a sorted linked list that has a tail pointer, because we really didn't use much of the double part of it. But as one last thing that I'll do, because it'll be really fast and I'll show you the power of the double linked list, is that so far, if we wanted to do a print function in this linked list, and we wanted to print it backwards, then we would have had to do recursion to print backwards in a singly linked list. Well, with a double linked list, you don't need to use recursion to print backwards. You can just use the pointer, the previous pointer, to do that. So for the final example, I am going to very fast code a linked list that prints backwards using just the tail pointer. So to do that, I am going to go ahead and make a temporary pointer, which I'll call cur, which is set not to the head, but to the tail of the linked list. And then all I'm going to do is I'm going to have my while cur is not equal to null. I can go ahead and say cur print, and then I'll put a cout statement at the end for the end line. And then instead of saying cur equals cur next like I normally would, I'm going to say prep, and that's what's going to make it go backwards. And so if I call the print backwards function now, let me see if I have all the code good. Yep, I think I do. Yeah, it looks okay for the most part. If I go ahead in here and say DLL print backwards, I think I put it in the wrong function, 31. Oh, I know. Scope resolution operator. Double linked list. Print backwards. Print backward. Double linked list. Print backward. Doubly. Ah, there we go. Yes, thank you. Good catch. Good catch indeed. There you go. Ghost is backwards now. So that is using the previous pointer to print backwards. So you're using the pointers to go in that direction, which is pretty cool. So and by the way, if you ever all class all the time we always do like ascending order, but to switch something like this to descending order is extremely easy to do. All you got to do is modify your insert function, which is here, and then basically flip the sign, I think, and that should take care of it. So we'll try it. So yeah, there you go. So now we flipped it. So now it's descending order. So you can see all the letters are counting down, which means that our ghost is backwards if we print in the normal order, but if we print backwards, it prints straight. So literally all I gotta do is change that line of code, and if I want to switch it from counting up to counting down. So like instead of doing 1, 2, 3, 4, if I want to store it as 4, 3, 2, 1. So instead of doing A, B, C, D, E, I want to do, don't let me do the alphabet backwards, but okay, E, D, C, B, A. Okay, so yeah, that is why the ghost would print that backwards like that. So anyways, that is a basic introduction into linked list, double linked list, and also the end of the linked list topic. So all that remains for us to talk about next week is going to be stacks and queues, which we should be able to finish within a class or a class and a half. So that will, yeah, go ahead and ask it. So that will be the end of the semester. So we should be able to finish stacks and queues in one day, but sometimes we end up running a little bit out of time. So if we do then the second class, then we will finish it like for the first half, and then we'll have the review. So I hope you all enjoyed the, what is like almost 2-hour lecture, I think. So now what is your quiz? So we have a train H, train CPP, and main CPP. Are we using train H for declaration and train CPP for the definitions of the classroom train H? I suppose so. I need to open the assignment myself to see it. Let me see. I know I saw that it was train related, but I'd have to go look at the details. So let me see. I saw the main is just very empty file though. Let's see, assignment 9, assignment 10. Main.cpp. So, okay. So maneuver the wagon, struct wagon, class train. Okay. So main.cpp, we need to ask the user once it's done, blah blah blah. Let me look for header in this .h. Okay, so include the file elements in your submission. Train class files. Train H. Yes. Okay. So what they're looking for is, yes, to separate it. So like if you wanted to ever make this into a header and C++ file, what you do is you would write, like let's say we were making the linked list class into 2 files. You would put this part of the code in one file, just this part right here, into the header file. And then I suppose this stuff in the CPP file, the train.cpp file. So, okay. So let's say we're doing the double linked list header CPP file and main file. In the header file, you would put this right here. This is all you would put in the double linked list.h file. And then in the double linked list.cpp file, you would put all of this code right here until before the main. That would go in the double linked list.cpp. Then in the main file, main.cpp, all you would put is this plus the include to make it compile. Oh shoot, my bad. Yep, apologies. Okay, so let me go ahead and run that again. So suppose that we were splitting it into 3 files, okay, and this will work for the train too. But suppose we were splitting the double linked list class into 3 files. We would have double linked list.h, double linked list.cpp, and then main.cpp. Double linked list.h would have lines 1 through 28 in it. That's all it would have, and you're done. Double linked list.cpp would have lines 30 all the way to right before main. So all of the function definitions, basically, or declarations. Function definitions, not declarations. Okay? All the way to line 183. So that would be double linked list.cpp. Finally, double link main.cpp. Main.cpp would just have the main. That's it. That's all it would have. And any sort of global functions if I had any. So that is how you would split it. Now for the assignment, what it's saying is when you're making your class, make your class declaration like you would with this, but make it a train one. And then all of the functions that are requiring you, which are like sort bubble, sort insertion, and swap, you will do those in your train.cpp. And then your main is just basically like, as we did here, basically running the test, which is be like declaring a train and calling the functions and that kind of thing. Okay? So that is how you're splitting the files, basically. Yeah, and there's nothing different. I think you've done this sort of splitting at some point with one of the other assignments. So just make sure when you do your compiling, you know, you don't compile things twice by accident. So like if you're just compiling one file, then you can do the includes, or vice versa, not have the includes, but then add all the files when you're compiling in the compilable file and whatnot. Is there an input file? I saw a file that was given to you guys. It's called traincompanies.txt. I don't know if that's just an input file or not. I think it is, but it's just literally like 5 lines. It's like 4, 10, 100 freight lanes, Amtrak, Metrolink. Let me see the file and see what it says about that file. It's called it's called traincompanies.txt. Oh no, that's sample output. So I guess there is no input. Yeah. So I guess there's no input. It should just auto-generate stuff, I suppose. No, but you know, I think he's got it messed up because You know why? I'll talk to him about this. But because if you look at the sample output on the 4th page, it says reading the train companies.txt file done. So I think he is reading in the names of the trains from text file, which would just be a bunch of cin statements, you know, or get line statements. But yeah, I'll double check with him. I'm assuming I'm like 99.9% sure that train companies is supposed to be an input file because of the sample output. So just kind of go with that, or if not, hard code for now. And he says that the first line is always 3 numbers separated using semicolons. So you can use getLine for that. You can do something like, I'll just leave it as a comment here. You can do like getLine. I think it's cin and then the message where you want to store it, which is a string. And then you can use a delimiter. So you can do something like that. I think that's the order. I might have the cin and the message part mixed up. Message being a string. So you can use that kind of reading in for the for that. Make sure you can just watch the replay, but cin message semicolon for the reading in of the first line. And then the next of them, it says the name of the train company is 1 per line. So for that, you can use getLine again with the default parameters, which is like just not have that 3rd parameter, or put it by hand like that. So that, you know, that's not bad. You should be able to do that in like 5 minutes. But I'll double check with him and I'll let you guys know. Probably like I'll send him a message today, and then hopefully he responds by tonight. It asks for error checking. I don't think it does, but if it does, it does. I mean, I think the only error that you need to check is that the range is between 10 and 100, and that it checks if the file exists or not. I think that's the error checking that you have to do. So yeah. Well, yes. Well, I was just talking about the input file, but yes, there's other error checking probably for like actual the main menu or whatever. Probably so it doesn't crash if you enter like weird things. For the sorting part, ooh, the Chrono Library. Let's see what the Chrono Library. I've used that at some point. Okay, so check this link out if you're, because it says to use the Chrono Library. So check that link out, and it has an example of how to use that. You basically don't worry about the word auto in that. I think at some point I mentioned auto. It's just it makes a variable be the type that it has to be. But all you gotta do for Chrono is put this line of code in your code, and then run your code, whatever you're trying to time. And then when you're done timing it, so like when you run the code that you want to stop timing, you run that again. So that's like start the chronometer and stop the chronometer. And then if you want to see out it, you need to basically subtract the beginning time from the end time. And this is probably kept in Linux time. So that's the third line of code there. And then from there, you can print that out with this line of code. Okay, that's all coming from that first link I posted. I will post it in the description of the video as well. So you probably need to know that because I've never talked about Chrono. You guys know bubble sort. You should be okay with that. Insertion sort, I would just insert it the way that that I did it in class, like, you know, the linked list example that you want to do. So that would make your life easier if you did it that way. So yes, okay. Is there any other questions on it? I think that's all that I can think of. Just looking at the PDF. All right then. Well, yep, I'm glad I could help. So this is the last assignment other than the final project per se, which I think should be out at some point within the next few days. But we'll see how that goes. But all right then. Cool. Well, I'm glad you guys stuck around. So I guess we saved, yeah, 45-minute class. All right. But yes, no class until next Monday then. Enjoy your Thanksgiving, everybody. I will be available though, because I am teaching my 302 class. That one we can't skip because we've had too many holidays, like screw that one up. So we have to have a class. I will be around. I'm not just gonna disappear on Wednesday. Okay? But have a safe Thanksgiving, everybody. Stay safe. Don't do anything scary, and you know, enjoy your time off. I mean, it is a long weekend, so good times for you. All right then. I'll see you guys next week, and take care. Bye.